Hello everyone, today I record a video to teach you in the topic how to use the module in the CATIA program for analyzing uh, state of state of your product, state of your product. Okay? And this case, I introduce you a change is the one of the component, one of the all component in the product. Right? I think it's one part to the CATIA program, and I use the generative structural analysis, right? For test the strength of your part, the strength of your structural, right? The structure is your part and how strength is it, right? And analyze where is the location. It should be proof, right? You proof and fix it because you need to protect that area. It fail really easy, fail easy and okay it's broken and fell down something, right? You need to improve where it you found about effect, right? And detect each area is very is broken and fracture easily, right? You need to improve that area. How do you know about that area should be proof, right? You need to use about generative structural analysis, right? Okay, let me show you how to use the CATIA for care. Care is a computer engineering, right? Okay, this program helps you support you analyze for engineering. Let me use it. Okay, take this new part first. You take your part is one component of product, right? That's it because this case is very easy. It's basic, right? Basics idea and basic command. Use the CATIA to solve the string problem. Okay, let me use about part of leveling product. I going to open that file. Assembly, right? Okay, we use this part, this bed part, right? Bed part. Okay, I open the bed part. Okay, I got it. The part. And maybe you should, right? If you need to keep state of that part, right? Keep state of that part, you can use and you copy that part first before you analyze that part and find out about its strength and the structure analysis, right? Going to the same location. That's it's original, right? Original. I copy the bad part. It's better because I need to keep the parameter and the current updated inside of that part, right? I should not touch the one of all this because I keep that right the assembly, right? Okay, I just need to create the analysis, right? Analysis. Okay, double click in here and pair this part, right? Okay, I got it. I close this the owner project file. I start up the one. Okay, I got the file. And this is the part I need to analysis, right? The one component from the labeling product. Right? and you analyze it. Okay, you need to create environment, write the real world, the problem, and you need to create that by using about the tool under the generative structural analysis. Okay, going to about it. I set up my select generative, right? Generative structural analysis. This this one. And part design. Okay, that's it. Okay, this is pop up. This is a warning message. So a warning message is tell me about right now part on my screen. Never assign about the material before, right? Okay, you have noticed and you follow up that warning you prove and you solve that and respond back to that warning and solve that warning. Statistic, right? Statistic analysis. Okay, you accept it, and this case basic. I will introduce you just only the statistic analysis. Right? Click OK here, and you assign about the material. Right? How to assign the material? You find out the tool is apply. You remember apply, right? Maybe you use that tool in the part design, right? Okay, you come back to the part design because the part design have. Okay, right now the part is coming here, right? Double click on there here also, and click here and open. Sorry, double click direct to the part and switch back to the part design. Okay, I find out about the tool, this one, right? Apply the material. You apply the material under the workbench is part design, the part design, and there is the apply material, right? And you click on there and pop up the tool library, material type, right? A lot of type, right? Okay, right now I use about steel, right? Okay, steel, and apply on here, right? Apply. Okay, like that, like that. Okay, I got it. Finish, right? And double click back to asset management. You see this is one element. It's an element, finite element, right? Because the finite element, right? Uh, the model, right? Finite element model. The finite element model mean you need to assign the small element, the small element, right? Represent to uh, some element in the part, right? So I mean in the part, right? Okay, assign assign the one element inside of the part, go along, go along all the part, all the material, right? Go along, even if the set right represent the mesh, represent to the material, right? The structure inside of this part, along of this curve, everything, right? Contain about the mesh in along of the part, right? And outside, what side the mesh? Yeah, you need to define the size of the element, the small element. And right now, the element double click inside. The element is octahedral mesh. Right, it's a solid mesh. Solid mesh in the 3D mesh. Right. Okay, right now it's or 9 millimeter, 9.4 millimeter, right? Okay, and absolute sec, right? The curve, right? The curve represent uh, under the 1.5, right? 1.5. If I add more, uh, 4 something, right? Okay, I try. I should I try it like this. Right? If I use it, maybe it's very big, right? Okay, this one is a big solid mesh. Okay, let me say, yeah, the small hole maybe it's not good, right? And this one is not matching about here. Maybe the hole is not circle anymore because this one is bigger, cannot represent around of the structure around the hole, the circular hole. It cannot represent the edge. The edges at all should matching about the solid mesh, right? Matching, align all of edges of your part, right? And this one may be the bigger, right? I will try. I try to use the all of the step, right? Using the command inside of the structural analysis and what the result, right? Show you better. And next step, right? And right now you got it, the mesh already, and the property, the mesh here. Double click on that. You can change anything. Right? You can change by use the ruler. Okay, you click on here, assign here, maybe okay like this. Should the mesh should be here outside of mesh, right? You can assign by yourself along by using about this way. This way define the length of the solid mesh edge, right? The edge of the solid mesh. Okay, click on here. Okay, 2 millimeter. We come to here, right? You can decide by ruler like this. Okay, again, you click on here, click here, and very big, right? Okay, right now I just click on here. Okay, 4. I did a 4 as well. Again, if you click on here, okay, 9 something. Okay, that's it. Fine. And come back again and define new mesh slide again. Double click on this one. This command box can be set up about the material, right? Right now I set up the seal material. Okay, already done. Okay, I set up in the part design before. Click OK. Okay, right now I already done 2 steps, right? And octahedral mesh, I call it. Another name is the solid mesh. And this one, the property, you define that like the seal property, right? You assign the in the module PR design, right? And okay, the material, right? Okay, you seal something. And last one, last step, right? Is static. The static case, right? Static case, you can assign on off 2, right? The 2, and this recent and load, right? And this the case, and because maybe you need to analyze case by case, a case you set up different element. Every case, okay, different, the case different. Maybe for the fault value different, maybe the environment different, right? And the fault type different, right? That one it can be a static case, right? And finally you can compare the comparison each other. What kind of fault uh, what kind of fault is the effect to your part, and because the location is fully about area critical state happen a lot maybe, right? You analyze different case is the benefit for you, right? Because you make sure about your part, pass every time for and every element is still be strong or not, right? Okay, maybe some benefit from the static case. Okay, I define about this. Listen. Listen mean how to assign your part, right? You enumerate, right? You you take apart to environment and matching between about the virtual and real world situation and matching each other, right? You need to know about if you take this part into the real world problem and real world problem and that then when you install the real world problem, what kind is the fraud act to your part? Maybe okay, the part this part is fixed. Is fixed at this area. Uh, okay, another area as well. Right? Okay, the fix and okay, fix mean it cannot movable. It cannot be movable mean okay, it fix that location. Still put right, not you can it cannot moving moving far away from this location that this part install in the real world. Okay, two part that you assign fixed part. Another load. Huh? The road mean the force. What kind of force? Right? You can see that on here. What kind of force? This force is the pressure. And this force is the distributed force, right? And distributed force. Okay, inside of the sub type force, right? And the five type, right? Okay, the three, right? And this one is the right. Is right the group import the group of four inside, right? Import the group is from outside, right? And right now I just this is the advanced, right? And this one is the basic. Use everything everything has inside of the uh, general structural analysis, right? Generative structural analysis of the module, right? Okay, there are three the submenu of the distributed fault, and this one is the acceleration, and this one is right for the density, right? Okay, okay, this line, the fault along two line, and this is the fault distributed on the surface, right? And define the density of the fault. If the fault may be dense and dense so much around the surface something I can define. Okay, right now I just use the distributed forward. I define about here, and okay, this phase being acted from uh, the fault outside external fault act to your part when your part stay in the real world situation, right? And how much of fault act to this surface, you can assign this bang box, right? Okay, right now I just okay define minus because I imagine I you assume this is better word. I have used assume that the part the part is being x to the external fault point to this the surface, right? And compress for it's compressed for that why I define negative 100, right? We can do 100 Newton, right? Okay, Newton is okay, approximate is 10 kilogram, 10 kilogram, okay, and the 100 Newton force, right? Okay, I click okay. And right now the force is it's the bill, right? It's the bill all of the fresh, yeah, the fresh. I selected before, right? And right now I need to take some command to calculating and calculate it result. Okay, result under the condition fix, right? Fix both side, right? And middle surface acted by the external force 100 Newton. Okay, I find out about the calculator using the toolbar. This one. Okay, click on here and the compute all. Click compute all here. Yes. Okay, I'm done. I'm done. Finish. Alright, this case. Right, this is case number one. Alright. Insert. That's the case. If you need to more, it needs more case. Right, you can insert. Okay, and after you have done analyze and calculated already, you find out about result. Right, the result is shown on the toolbar. It's a control the result using the toolbar. Okay, I find out the tool. This one, this one, this one. This is the toolbar. And you click the first one, deformation, and the deformation. Right, do see about is bigger the circle edges. The circle edges is not circular shape, right? Because the edge is the mesh edge. The mesh edge is not compatible with the edge of the circle, right? And it's bigger if the mesh bigger, and the feature of the part, the circle feature, and okay, it's lost the shape, it's not exactly matching the shape circle, right? That reason, uh, the calculated the model is not exactly correct. Accuracy maybe is dropped down because the mesh is bigger. The mesh is not good. It's not matching about the shape of the shape the shape of hole, the shape of curve, something. You see it? The curve is not good, right? Like this. This is the reason of the element, the small element. The small element, the result from analyzing from the CATIA program. This is one element. We get the result. Deformation, straight, one is straight, right? And displacement, everything. It conclude inside the one element, and one element represent the part shape. Okay, part shape, and represent the part shape using a lot of the part shape, right? Depend on the mesh shape as well. And right now the bigger uh, represent over all of the feature, all the feature whole everything. Okay, it's not matching it, the result is not good right here. Okay, this is the deformation. Okay, if I use it more second, this one is right? Deformation already done, and right now I click again, second image and second toolbar, and second command, one mistake, right? One mistake right here, right? Okay, I will use show shading with material, right? I change the color. It's change the color. The color is told me and tell me about that. It told me about how much is state, how much is the right, the state and strength and it's right the strength happen around of your part and how much the state right relates on the color. The color rate mean maximum, right? Maximum here. It is okay. If I add up about edge, right? Edges allow of the part, and right now it's gone, right? All right, gone. If I call it back, you will see about the element, small element, right? And the edges of the mesh element allow this, and right now it's gone. You will call it back. You use it. Sorry, you use it. Customize view parameter customer views parameter, you added edges and points, right? And right now, okay, still be shading with material and add up edges and point, right? Okay, you will see about the option you tick on material, right? Okay, something. Okay, you got it, the result. Uh, okay, you go into another analysis, right? Okay, this one is the one we said. And if you need to show your result, right, the animation. Okay, this one animation, you can animate it at your part, right? After it's added by the font and environment like this situation. Okay, tick it here. Uh, you can slow down. Okay, when the font compressed to this phase, right? And this phase generate is straight because it's acted by the fault, right? And okay, the result from this program is show you about 5 points well, I find about 10, 10, 5, 10, 5, right? Uh, 10, 5. All right, 0.5, 0.5 megapascal, right? It's megapascal. Okay, 0.5 megapascal, 10, 10, 6, 10, 6 power, right? Then the peak 6 power, megapascal. Okay, animation is the you see look like it overacting of the animation because actually it not moved so much like this, like, because it's really clear about actually it's a move and acted by the force is a move to this direction that just show you like that, and it's not exactly about the deformation or loss and so much like it, right? Because this program add the amplifier factor, right? And extend about the acting, extend about the acting. It's overacting. Okay, close it. Okay, next, let's see. You can see about this pen, right? Yeah, you can see the pen. If you move it, move this, right? And move here. right? You see inside of the part, right? You can, okay. And this next is the amplification. Amplification is right big. It look like it's overacting or of the force. For the act two, the part is over. Right, the animation and deform is so much, right? And it's over because very clear to look at to the response uh, to respond of the force, right? The part is acting back, right? And something like that, and show it and really clear. And it's too much, right? It's a scale, right? Okay, this one enough. And define the maximum. Define the maximum, right? Okay, you see here, define the global maximum to the local estimator, right? Okay, the point is pointing to uh, where is the set, where is the pop up, where is the generated, uh, the maximum state, right? And this command is show you where is the location the maximum state happen. Right, okay, click here. And this one, right? Maximum. It's global maximum, right here. Global maximum. Yeah, it's over here, right? It's over here. Maximum. Shows you 0.512, right? Megapascal. It's megapascal. Ah, okay, you see next button. Next button. Okay, this one is show up the maximum point. And next is information. You click information and you need to see about one mistake because state is important, right? It stays over the yield state and your price it fail. If I is broken, right? Uh, like this, you make decision. You can decide about your part is your part is good or not good when the raw part uh, when your part using inside in the real world side. You change your real world side and your part it can be endurable or not, right? This is important. This is why did I show you and teach you about using about generative structural analysis because it's a benefit for you design the virtual model. You currently your part it can be used in the real world problem or not, right? And can be durable when that part acted by the real fault, right? The real fault, how many fault, and your part can be survival, right? It's not fail. How much fault, right? You need to use it care, right? This one, right? The uh, computer engineering helps you analyze the what happened, your part uh, fail, right? You can you come back find out about the reason, right? Okay, this next one. Ah, use it information. Click on here. Is make sure about if Ford add to your part 100 Newton. This one maximum, right? 0.5 megapascal, and minimum is the six, uh, 0.06 megapascal. And this one is a property of the material because your part created here that it's from the material steel, for this, the steel, right? The steel have the property like this. Okay, 1 to 1. Okay, Young modulus, right? Young modulus, and boson ratio, density, and thermal expansion, and yield strength. And it, okay, it relates on is fail or not. It's a failure. Failure. Your part is failure or not. Uh, under the some force, right? You limited the force is protect your part, it fail, right? And the goal is our goal using about the tool, right? Okay, right now it proved it. This and this part is survival or not, right? It can be durable and 4 Newton, 100 Newton force or not, right? And right now you're saying is the property of the seal, right? And this one see 2.5 and 2.5, 10 8 power, right? And this one is maximum. Maximum is 0.5 megapascal. Okay, do compare each other. Oh, this one is higher than the real state strength, real state, the real state on your part, right? This is a maximum already, right? Under the 100 Newton, and the spec and the criteria of this material, right? Okay, it can be durable. Can do and durable is okay, can be it's tough enough, right? It's tough enough for 100 Newton, something like that, right? Okay, you analyze by using information, right? Because it's lower than the criteria. This one it's criteria of the steel material, right? The steel material. Okay, it close. We add up another static case. Okay, another static case. Static case. The new you need to create a new descent and load. Is loading the same or not? Right, and loading the same, right? The multi load or not, right? Okay, you can define, right? The case mass or not, mass, and this one, right? Okay, you accept it. Problem, right? The listen, and this one the sensor. I will use this 10, and right now I need to change. The mesh slide. I need to change. Okay, I right now I need to show. I click on here and okay, I now did 2 millimeter. Okay, 2 millimeter. Now here, and this one, oh, it's 1 millimeter. Yeah, 0.8, 0.5. Linear because the edges, most edge, right, the straight line, right, and just this one, and circular curve, right? This curve, the circular curve, right, and represented by the straight mesh, right? Maybe have the step it's not smooth, right? Okay, no problem. And if you create a small size, and okay, it's consume about the computer resource and use a long time to calculate it. You need to test off each other because it's bigger. The model, the mesh is bigger. It's not good to represent the mesh to the parts, right? And if you is small too much, and your computer uh, is consuming consume the resource in your computer and take a long time to calculate everything, and environment allow of your part and the fault in your part, right? And calculate each other mesh by mesh, right? Because you made a lot, that means to take the time to calculate each result of the mesh. Okay, transfer to another mesh nearby, to another mesh, right? Okay, right, the mesh never a lot, right? That you send the result to another mesh, send to another mesh, right? It take a long time. Okay, test is my computer. It depends on your computer as well, because the computer is your high performance. Okay, maybe reduce the calculated process process is result time, right? It's reduced. Okay, shorter. Then it's a high performance. It's shorter the calculated process time. Right? Okay, click okay. Right now it's very small. And this thing, I change my mind. Okay, my situation, I will take this one to the real situation and need to fix it. Attach, fix on the white on the wall, right? On the some part nearby, right? Okay, and the fourth right now I use the this one. I'll click on this. Oh, I forgot. Okay, I click okay. Click for okay. Click and this the view font. It's a view font. Um, I just handing to here. I need to point here. Right? 200. Okay, 200. Okay, you use your sen. Use your sen. This is a point load, right? It's a point load. 200 Newton. It's a point load up to the corner, right? At the end, the corner. What happened? Can you imagine? Uh, can you imagine about this? What the result should be, and how affect, right? How affect does it? How affect does it take, right? After you push the forward at the corner, okay? You analyze, you assume, you picture yourself, right? Okay, and if the result is pop up, okay, it makes sense or not, right? You can prove it by your mind, by your knowledge before. Okay, you click that and support, right? And it's point load, right? Point load. Click OK. Okay, calculate. Okay. Oh, okay, take time, right? It's longer than previous. And still, for me, I think it's fast enough, right? Okay, result. You see, image. It's curved. It's curved, smoother than previous. A lot, right? So improve the mesh represent to our part, my part, right? And here is still is not good, right? And still smoother than this one is very clear. It's smoother for sure. Okay, for sure. You see about one mistake. Yeah, one mistake, right? You see here, and it's not right. It is the factor is right here. The factor is not too much, right? Okay, you see the red color over here, the red color over here. This one is 43 megapascal. It's maximum 43 megapascal, right? Okay, you see here. Okay, uh, and it's so much of straight. It's a red color and 43 allow of this side, right? And on this side because this is 200 Newton. We focus on this corner, right? Okay, I show you the its animation. And, okay, and find out the maximum. Maximum, click OK. Hey, over here, maximum is over here, right? This this one over here because it's correlate with the fraud and the fraud where the fraud act two and the one mistake for a line of the fraud location, right? Okay, it makes sense. Okay, how much and what effect and the 200 what effect this steel material is overpriced or not, right? And is the exceed the the tensile strength and exceed the yield strength or not, and I compare it with the one we said. Okay, here static case is one we said, and okay, in the maximum, this one 8, right? 8 and C 0 0.2 uh, 0.2 no, no, 250 megapascal, right? It's spec of steel material, uh, 250 megapascal and 43 megapascal. Okay, is lower than the criteria you say, right? Okay, it can be endurable, right? It can be durable. Uh, okay, that's it. You can use it one this part and this experiment fraud. In this experiment fraud allow of this part in the world real world station real world the situation is it can be endurable, right? It can be used under the condition, right? Under the condition it fraud and experiment, right? You put it before you take your part into the situation, the real situation, right? You need to put it real first. Okay, you can show up about here. And you show up here. This one is the vector deformation. This is a displacement, right? Is the red color is a 3.0.3 displacement, right? Go down. This maximum 0.3 millimeter. You accept or not? Right? Okay, you wanna write. Okay, you see where is the problem? This one, because this one is the fourth point, the fourth act to this one, this point, the corner is cause this displacement too much, right? And no, it's not too much. Depend on you accept or not. And if you accept, it's not too much anymore because up to you, up to uh, designer person, right? And it was 0.3 millimeter. You accept or not, right? You admit it, you admit it or not. Okay, 0.4 or something in this occasion. If you accept, okay, it's passed, approval, right? Uh, Okay, if you come back, right, you can deactivate, right? Deactivate it. Okay, it's gone and you show up. If the result, right, is more than one, you can switch each other. Up to you. You need to know some result, right? Different And if you need to see about deform, right, you act here. And this one both, right, you deactivate it. Deactivate it. It not not using the calculated, right? Not using the calculated. It's not calculated. The program is not. This result, right? One measurement is not calculated by program. And right now it's just the deformation is show up on your screen. Right here, right? Deformation something. Okay. Because it's an amplification. I said it's is lower. That means it not see anything, right? The state and actually it not straight. It not straight, and it being affected of uh of a deformation of the part. I have information of the part. If you add up the factor, right, you see here, right, that this is the benefit of this magnitude. Amplification, magnitude, right? Okay, I take that. And this is calculate computation mean the file, the result file. Uh, After you calculate, right, paste on the compute, and the result is keep inside of the computation, the location in your computer, right? And this one, the result is the both. If you take it, right, you take both, send to me, and I open your file. The result is attached each other to your result to me, right? And it can open and automatically it show up on my screen, and the real result you can calculate it in your computer. Then right now you send to me, I have the result show my screen, right? Okay, I bring you to save management, right? The management is the result, right? The compute and result come from here. And if you take all of that, right, save on that here, and you focus on this module, extension of this module dot cat analysis, right? It save as in the analysis folder. I set it up before, and I save it, right? And I paste propagate directory. You will notice the location of your cat file before and right now. And this one, the temp, right? It's temp analysis dot something cat analysis. So, and this is the default come from here, default folder. You press calculate button, and on the result put into here and the default. And right now you need to save inside your work folder, right? I click on here. It changed right now. The result is saved to the work folder. Okay, you need to do write this, right? Because you need to submit that file to me. If I assign your work, you need to submit to me. You follow up about this step, right? Okay, I save it. Oh, okay, it's done. This one is the material, right? By the way, I will guide you something, and the property of the material is show here. Okay, to switch back to the part, right? Switch back to the part. The part is a material, right? Material. You look in the material. Steel, right? You can adjust uh, the reflect, right? Adjust everything needed on writing, transparency, something, right? You can assign by yourself. You can add the picture. You can add the picture image. You can add the picture to the material. The material, if you change right? You change the style. If you change the style in the default library, it change too, right? If you need to keep it, keep still okay. That let the parameter at all, like the default is better, right? Not you didn't touch the parameter of the default library, right? Okay, you cancel. You need to adjust anything in the default library. And if you need to adjust, up to you, up to you. Uh, take care. You can download the image, represent the material, color, material, the material, uh, material pattern, and you can use the image, right? Here, the material pattern, paste on the part, right? Up to you, image. You can load the picture, right? And this one is the default, right? And for me, I don't touch it. Okay, I don't touch it. And another way, if you see here, the material in this library, okay, thought thought of thought of about the tab, right? The tab. Did the program sort of about the tab like this? Okay, tab is a stone or something. Have the property itself or the activity itself. If out of this is not matching your work, maybe you take the PLA material, the filament of the 3D printer result, right? The model, it never have inside of the category, library of the material it never have, right? Because this one is a property, deliver here, apply here, and this one analysis have itself, have the property itself, right? This one I keep that like the default, right? And maybe you need to add more the material, integrating material because you need to apply your result to some work, right? Okay, you need to, maybe you need to create a new material for yourself, right? Okay, you're going to add uh, for infrastructure and material library. This is material library you can add up if you need to add more, right? Add here. You need to add more, right? Right now, I show you just only one. Double click inside, right? Maybe you add the name. Okay, you click on here, you can rename the material, right? Okay, PLA, maybe PLA because the 3D print material. Click OK. Double click inside the material. You need to assign about property, right? You find out the the value and property of the PLA using the Google. Okay, right now I got it. You search, you search, you search in the on the internet, right? It show you here. Okay, this is density the uh, 21 to 60, right? Okay, define like this. Okay, maybe find out about another in the material. PLA material property. Yeah, yeah, image, something like this. Same density, something. Okay, I assume I random is one of them. Okay, I set up young modulus, right? And Poisson ratio, Poisson ratio. Okay, Poisson ratio. This one, I think Poisson ratio, this one is the new, is Pascal, is Pascal. Young modulus, 0 point. Uh, stress, stress is this you strength, right? You strength 21 to 60 megapascal, megapascal. Okay, so, I think it's 40, right? Because 21 to 60. Okay, so I use 6, 20. You can adjust, right? Maybe you pop out the idea, you experiment and you experiment the PLA, you go into test, synthesize test everything, and you get the property exactly value property of the usage. You can fill in here, right? And right now I assume using about the website is guide me, right? And 21 to 60, I select on 50, 8 or 40, right? Okay, 10, 6, I cannot. Uh, 40, maybe E, I don't know, E, 10. Sorry, I try. 6, okay, 40 megapascal, right? And row density, and proton ratio, uh, okay, 2.5, right? 2.5 to 6, right? Proton ratio, uh, 4, okay, 4. You can calculate and convert the unit, right? And it's gram per cubic centimeter, right? Cubic centimeter is convert to a kilogram cubic meter, and cubic meter. If you use the calculator, it's convert unit. Pass the website. The website is convert density, right? You will get it. You will get it about here 1 point, maybe 1.23, 1.23, right? You will get this result to here 1,000, 1,000 to 30 here, right here. Okay, got kilogram cubic meter, and this young modulus. Okay, I see. Is E young modulus 0.4. Okay, 0.4 gigapascal, and convert to megapascal. Right, you need to convert to megapascal, become to megapascal. And this one is okay. This one is megapascal, right? Okay, I use it 400. 10 E6, right? Oh, sorry. 10 E6. Okay, direct to here. Right here. Okay, focus on Pascal. This one, 0.4. If 0.4, 10, 9 power, right? 10 9 power. Okay, I get it. Get it. 0.4 and 10 E9, right? This one. Okay, like this. Gigapascal. And same thing. Okay, this is everything I found in the internet, right? This one, 40, right? It's 40. I use another way. I put in here 40 times 10 E6, right? Because it's a megapascal, right? In the data, megapascal is 10 6 power, right? 10 to pick 6 power, right? Okay, right now finish, apply. Okay, good. Same thing, right? Okay, I accept it. I fill in the parameter already, and if you use use this, right? The color, oh sorry, the color. Okay, effect something, you can use it with the material, right? You can define, right? You can define everything. Chatbot. This up to you. You can define, right? In the color here, the color. Let me use it. It's okay. It's okay, right? I saved it. It saved it's a cat. The CATIA material, right? Okay, save. Change PLA. Save. Okay, you come back. Come back. Analysis. Right. Okay, come back to part. Okay, you click on here. Right. You're going to browse the PLA. The PLA you have done before. Open. Okay, here you click apply. Apply the part. Apply the material. Okay, it's become to here. I use change the material here. There's the material. The material, right? This is the texture. You fill in the PLA library material, right? You assign. Double click on there. You this one, the value you set it up in the PLA material, right? Okay, this is the customized material. This is customized material, right? You can do this. You can do this. Okay, if you need to analyze the real material you use in your part, you build it by the 3D print, right? You find out about the property of the material, right? And fill in the material library here, material library, right? And define the new material. Okay, this one of thing about the analysis, right? The care computer engineering technology, right? I use the generative structural analysis in the CATIA, right? Okay, right now, enough for now, right? I need to leave this video